Alright, so number 8, Wiiley number 8 was kind of quick. So at number 8, okay, so it says the homologous series of primary amines CH3 CH2 to the N NH2. So the homologous series, I guess, is this part right here where it's just a chain of CH2s. It's a chain. I'll look up homologous after I'm done with this. From CH3 CH2 3, so there is a homologous series of 3, so it's CH3 CH2 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 NH2. That's the way the molecule is. So it says they all have their base peaks, their base, which is the largest peak, at mass divided by charge 30. So they want us to select the reaction that shows the peak that is found in the mass spectrum and how it is formed, right? So select the reaction that shows the peak that is found in the mass spectrum and how it is formed. Okay, so just some background info on base peaks, right? So I'm getting this from page 426 from Solomon's and Friel Organic Chemistry 10th edition, and I'm looking at figure 9.35. So they say the most abundant ion, which is the tallest peak, is called the base peak. The base peak is usually an easily formed fragment of the original compound. So, right, just quickly, usually, so when you first take the compound and you ionize it, you get the regular M, the M value, which is, it's pre-fragmentation. Sometimes the molecule doesn't fragment, like in that one example we saw, I think it was ethyl bromide. Doesn't fragment, so this is the base peak. However, when it does fragment, when it often does, because it can easily fragment, that fragment is the tallest peak. This is the original compound. If the original compound easily fragments, this is not going to be the tallest peak. It won't be the base peak. If it doesn't easily fragment, it will be the base peak, it'll be the tallest peak. So they're saying that obviously this compound, this homologous series of CH3, CH2, or blah blah blah, CH3, CH2 to the 3 NH2 obviously does fragment because the mass charge is 30, and this by CH3 plus CH2 to the third NH2 is much larger than 30. So they want to know why that happened and how it is. So they gave you a bunch of examples, and they gave you a bunch of choices, and it was kind of by deduction, or I think that's the word I'm looking for, deduction. So here's CH2 connected to NH2. So I guess there's like R is the homologous series. It's the CH2s and the CH3s going this way. So you ionize it, right, and the N has a lone pair of electrons. The nitrogen has a lone pair of electrons, so it's the one that loses its electron and gets the positive charge. So this fragments, I guess, sending one of its electrons here, one of its electrons to the R, which is that homologous series chain, and then the nitrogen donates its electron to this bond, and it forms CH2 NH2 with the positive over the N plus the R, which is the radical that left. So just quickly, yeah, some time. Let me look up homologous series. Oh, here I am in Wikipedia. Homologous. And maybe I'll put this in the comment box. Homologous series. Okay, in chemistry, a homologous series is a series of compounds with similar general formula. Okay, I'm gonna put that in the comment box of this video so you can look up what a homologous series is for yourself. Alright, thanks, bye.